So I'm going to go through a few examples. So what you will need to do is have your books out, ready to go.
Y
What was
equals
this?
X, just like a straight line where if Y is 2, then X is 2.
Yes.
Okay.
And this wasn't working. Stop working. Right, so we're going to graph our linear relationship, but before we get on with that, can you just remind me about linear relationships? Tell me anything you know.
There's a constant change.
Okay, so we've got a constant change. Here you go.
It's the line is an infinite number.
Okay, so a line is an infinite number of ordered pairs, which is basically the x and the y value that are related. Yeah? So you find y by doing something to x. And if it's a linear relationship, that relationship will look like a straight line if you plot all the points. Alright. So a line is an infinite number of points. Anything else we know? What's that? So gradient is
The constant change.
right. Oh, good. Okay. Rise over run, which is also a nice straight line there. The constant change. So that works out what we are applying, whether it goes up, whether it goes down. That is the gradient. So we'll do that. It has here as well. Remember, we did the fateful criterion B about the axis intercepts. What is the y-intercept, the y-axis intercept?
0.
Not always.
No. It's where Y intercepts the.
But we know
vertical
something
line.
else that came from that assessment.
Oh.
Yeah?
Where Y intercepts the line, X will always be 0.
Okay, good. X will equal 0, which we have in this, a lot of these in linear relationships in context. We call that the, you remember? The initial condition, yeah. Where it starts from, right? And there's one final thing. What's the general form of a linear relationship? We were to put it as an equation. Y equals mx plus c. Which is which? Yeah.
I don't know.
What's m and what's c?
Oh, m is the gradient, c is the y.
Yeah. Okay. So we've got the y-axis intercepts. The initial condition is the plus c, and the gradient is the f. Rise over. Okay. So that should tell us everything we need to know about gradient. So we've done it before. We've still got some papers on the wall. We can express our linear relationships as a table of values, a word problem if it's in context, a graph, going to be a straight line going up or down, and an equation. So we started that off matching those. So now we're at the stage of, well, if I'm given an equation, how do I do the graph? Right. We've gone from if a word problem, how do I find the table? From the table, find the graph. Now we just want to go from the equation to the graph without having technology to do it. So we are looking at mx plus c or ax plus b, up to you. All right. And we're going to be graphing this. So you might not want to draw this just yet until I've done it, just in case we have to change anything. Or you think, oh, maybe I should have just drawn it in a different way than this box did it. All right.
Wait, can you scroll up?
So, let me ask you this. So David actually already told us what y equals x kind of means with the relationship between x and y. Did anyone hear it?
They're the same.
They're the same. Remember, we're looking at a relationship between x and y. So if x is 1, y must be 1. If x is 3, y must be... So that's actually one way of plotting this line, is just to think, well, if x is 0, y is 0. 1, 1, 2, 2, 3, 3, negative 1, negative 1, and so on, yeah? And I could happily just draw my line like that. Alright, so that's one way of doing it. Now, can I just ask you though, what is the y equals mx plus c in this case? What is m and what is c?
M is 1 and C
M is 1 and c is
0.
0. Because the initial condition is 0. M is 1. Well, that means that as x increases by 1, y also increases by 1. Rise over run being 1. If I do one thing divided by another thing and I get the answer 1, what do I know about the two things?
They're the same.
They're the same, yeah? So if I do rise divided by run and I get 1, I know that the rise and run must be equal numbers, yeah? So in this case, do you remember doing, if I go across 2 and I go up 2, I get 1. Yeah?
Sorry, what is the C and the Y intercept?
Be an initial condition.
Yeah. So C, if I make x 0, what will y have to equal?
0.
0. So if I have to add something on to 0 to make 0, it must be 0. So my initial condition, what will y be when x is 0? Well, in this case, it must be 0. And it's also where it crosses the y-axis. So where does it cross the y-axis?
0.
At 0. Yeah? If we have maybe made more sense, that was quite a difficult one. That's why I kind of put this one in, even though it's the first one. Let's have a look at D. All right. I'll look at D. I've missed out B and C because you're going to do them for yourself. All right. But I've picked a couple of examples that give you a know-how of what to do in each case. So let's analyse this one. All right. So again, we're looking at the y equals mx plus c. In this case, what is m? Not as difficult as you might be thinking it is. Negative r. That is
Negative
m.
0.5.
Well, I'm going to leave it as negative 1 over 2. There's a reason for that. What's the initial condition? Negative 4. So that means when x equals 0, y equals negative 4. Right? So what does that look like if I try and graph it?
So
I'm going to put my line up here, you see. Why? Well, because where does it cross the y-axis?
0.4.
Negative 4, yeah? And see, so I'm going to go down and cross at negative 4. Alright? So that's the first bit done. Alright? So when C is negative 4, that's because we've got negative 4 there. So we've got a crossing point. The y-axis crosses at negative 4. Now, why did I leave the m as 1 over 2 and not change it to 0.5? Any ideas?
no.
What's another way of saying m or gradient? I knew you shouldn't listen to other people. You should say what you're going to say. Yeah. N is rise over run. 0.5 is an easy one. It doesn't mean much, but 1 over 2 is nice and easy to work with. The fact that it's -1, well, what does this mean? That the rise is -1, and my run is 2. So how does that work? Well, we know we start at -4, right? Happy with that? So what do? I drop 1. My rise is -1, so I have to go down 1, yeah? And my run is 2, so I go across 2. So there's my next point. Down 1, across 2. This time, across 2, up 1, because I'm going the opposite way. So my line like this, and because I left it as a fraction rather than turn it into a decimal, that's what my line is going to look like. Right. Make sense? Okay. Pause, but I need to use my boots. And I'll let you draw that out, and then so let's just have a look then. First of all, let's analyse this. What is the gradient, the m value? 2. All right. That means that the rise divided by the run has to equal 2. So what numbers, when divided, give me the answer 2? 2 divided by 1. 4 divided by 6 divided by 10 divided by any of those that you like. So my rise can be any of these as long as the run is what goes with it. Okay, what's the initial condition? So positive 1/2. So let's look at this. If I were to draw my axes, I'm not going to go too far into negative. Right? Assuming, like I have been, that each square is worth 1, where do I cross the y-axis? No. No.
0.5.
1/2, yeah. So this value here, right, the plus 1/2 is where it crosses the y-axis, yeah? So my first point is at 1/2. Now that's going to make it challenging. Yes, you.
How do you know the half is C?
Because it's the without the x. So you remember when we started this, the gradient, as we've already said, Zach was saying, the gradient is the change. Yeah, it's a constant change. So if I go up 1 value in x, which number does that affect? The 2 or the 1/2?
2.
The 2. So if x goes from, if x is 1, this will be 2 lots of 1, yeah? If x is 2, it'd be 2 lots of 2. If x is 3, it'd be 3 lots of 2. If x is 4, it'd be 4 lots of 2. So this is the change.
The initial condition is the 2.
No, the initial condition is what happens if I put x is 0 into that. If I put x is 0 there, what does 2 times 0 become?
0.
So I end up with 0 plus 1/2. So y would be 1/2 when x is 0, yeah?
Wait, why are you saying M and C? Oh, never mind.
Got it?
How do you get 2 to 0?
Right, so the relationship is, what's the relationship between x and y? Well, take x, and what do you do to it?
Multiply by 2.
Multiply it by 2, and then
Add 0.5.
add 1/2. So, the initial condition is where it starts on the y-axis. What is the x-coordinate when the point is on the y-axis?
0.
Okay? Got that?
Yeah.
Because wherever that point is, This will be 0 on the x-axis, yeah? Right, so let's figure that out. If x is 0, it would be 2 times 0 is 0 plus a half. So y would be a half. So that would be, it's a half. Now, what's the quicker way of rather than having to put x 0 all the time is when it's in this mx plus c, well, if it's m times x, if x is 0, this bit's always going to equal 0, right? Anything times 0 is 0. So the c is what's going to happen every single time when x is 0. And when x is 0, we know that's where it crosses the y-axis. That's why we did that assessment. Okay? So if we go back, look, all of these, look. This one, mx plus c, well, we knew c was 0 because there was no adding anything on. This case, c was -4. So look, if you do it, if x equals 0, y will equal -1/2 times 0, subtract 4. What's -1/2 times 0?
0.
0. So we end up with 0 minus 4, which is -4. So y equals -4 when x is 0, which is just that number, right? Now what happens if I say, well, x equals 1? It would be -1/2 times 1, which is -1/2, and we add that to -4. So it would be, y would equal -5. No, sorry, -4.5. Yeah? If x is 2, it would be y equals -5. So every single time we add 1 to the x, the y value will change by what amount? This value here, yeah?
Yeah.
So the line will go down this time every time. Yeah?
Right.
But it will start at -4. Well, we say start, but we don't really mean start, do we? It's called the initial condition only if it's in a criteria D context. But no, that's not starting anywhere, is it? It's just a single point that we say is the initial condition. But we can go left, we can go right, and go on forever when we've got no context to it.
Anything could be
And so this one, we know that if I go up an x, what does the line do? It goes up 2 every time, yeah? That's the constant change. Plus 2, plus another 2, plus another 2. Where does it start? Well, it starts when x is 0. And when x is 0, I know y is going to equal a half. So I put that half in, and then I figure out, well, when I go across, when I run 1, I rise 2. So from this point, I go across 1 and up 2, which will actually take me to 2.5. So it's a bit tricky. So I put a point there. If I go across 2, I need to go up 4. Yeah, if I go across 2, I go up 4. So from this point, instead of going, I could have gone across 1, up 2, but I could also go across 2, up 4. So that's 2, that's another 2. Look, if I do that, am I getting a straight line?
Yes, you are.
This way, if I want to work the other way, well, I'm going to go backwards 1, and I have to then go down 2, because I'm doing it in reverse. And then
Backwards to
You
down.
just draw your line.
I just draw my line, which is the important bit, because if your lines are not done very well, your points could be off, and your line will be wrong. And when I give you an assessment, if your line does not match where it should be, you're wrong.
I will
Don't do it on purpose then. Alright. Does that explain anything a bit better?
Yes.
Yeah.
Yeah. So we've got to make sure we keep the links together with everything. Alright. We ready to have a look at this final one. Not just yet. And let me, I'll leave you to look at it, but I'll pause the video.
I'm looking.
Before we move on, I would like you to give me some stories about these. What could they represent in real life?
For every dollar you spend, you gain 2 candies for D.
Well, let's do A first. Okay.
With my-
But I like the idea that you've come up with. What could this represent? Okay? Yeah, could run that. I'd like different things, like if I work 1 hour, you give me
$1.
$1.
That's
It is, yeah. 1 minute, $1.
That's a lot.
Yeah.
$1.
I can't win. Too much, not enough. All right, so we've got that one. That's quite a tricky one because not many times in real life do we actually have that situation. But this next one,
Every dollar you spend, you get 2 candies.
no,
Why not?
because it goes down a half.
every 50 cents.
Every 50 cents, you get 1
But
candy.
Every 25
where does the -4 come in?
I'm in debt.
That's where it's got to be in context, doesn't it? We've got negative numbers here. We need to give a reason.
Keep robbing me.
Sales are down.
So talking about debt, because you've gone straight into debt because of negative numbers, you've started talking about it. I currently owe $4. Yeah? I currently owe $4. All right? Every 2 days that goes past, I owe another
Interest.
$1 in interest. Yeah? So my debt goes up $1 every 2 days. Does that make sense? I'm trying to make the links back to what this could mean. This one. How about in the bath, there is currently ½ a litre of water. What does this mean?
Every 2 minutes, there's another half liter.
Another liter.
Every 1 minute. Good. The change is the 2 litres, yeah, per minute, per hour, whatever you want to say. But for one, the run, right, is the unit that's going up, right? Or we go along, whether it's time, whether, you know. So 1 minute is another 2 litres. The change being 2 litres every minute, yeah? What about this is a slightly different, well, it's not different, but it's just the same thing, but written in a different way.
There's
Which we
3
get.
apples.
Okay, so first of all, let's think about M, which is the rise over run. What is it?
-2/5.
Okay, that's the -2/5. Now, what is the common mistake? The position, yeah. People go, the M is always first, but it's not.
Wait, so that means I did
Is it a negative? Yep, it's not a negative.
that? Okay, well I just
It
have to-
must include the negative.
Wait.
All right, it must include the negative. Right? Remember, the change is what, when I go up by x by 1, the constant change being the gradient is what I multiply x by. So if you want to remember it like that, the m is what you multiply x by. The initial condition is not affected by m. Sorry, is not affected by going up in x. The initial condition is there to start with and then never again, right? It does impact everything else, but only at the very beginning. So what's the initial condition? 3. Is it a positive or a negative?
Positive.
Positive. Why is there not a plus 3?
Because
If we don't, yeah, it's assumed because it's the first number we don't need. If it was a negative,
it would have.
it would have a negative. Why is it written this way round then?
I don't know.
No, it's not about. You will see this regularly. The reason why it's written this way around is a convention for algebra, which is you try and keep things tidy, Sam. Which is if there's a negative and a positive, you put the negative afterwards. So you write it as a subtraction rather than as a negative. So this could be written as y equals negative 2/5 x plus 3, but we consider that to be messy. So we rearrange it. Remember, we block that, and we block that, and you can write them any order you like. So we just decide that it's a bit nicer to have the positive at the beginning because you don't have to write positive. Yeah? Does that make sense? So bear that in mind. It's not just the order. So we've got, right, how then do we draw this one? Start at 3, yeah. And start at 3, because that's my initial condition. Why? Yes. We go down 2, minus 2, and across 5. Yeah? Down 2, across 5. We go the other way. We go up 2, across the other way 5. And there we go, some points. Right? And then I can draw my line. Is it starting to come together now in your heads?
Yeah.
Almost time to finish, I think.